Question 5. This question is about the preparation of hexane 2-ol. Hexane 2-ol does not mix with water and has a boiling point of 140 degrees Celsius. Hexane 2-ol can be prepared from hexguanine using this method. A. Measure out 11 cm cube of hexguanine into a boiling tube in an ice bath. B. Carefully add 5 cm cube of concentrated phosphoric acid to the hexguanine. C. After 5 minutes, add 10 cm cube of distilled water to the mixture and transfer boiling tube contents to a separate funnel. D. Shake the mixture and allow it to settle. E. Discard the lower aqueous layer. F. Add a fresh 10 cm cube of distilled sample. Add a fresh 10 cm cube sample of distilled water and repeat steps D and E. Transfer the remaining liquid to a beaker. H. Add 2 grams of anhydrous magnesium sulfate and allow to stand for 5 minutes. I. Filter the mixture under reduced pressure. J. Distill the filtrate and collect the distillate that falls in the range 130 to 160 degrees Celsius. 5.1. It is important to wear eye protection and lab coat when completing this experiment. Suggest with a reason one other appropriate safety precaution for this experiment. One other safety precaution. Usually when I ask this, we could talk about wearing gloves because we're working with corrosive chemicals, or hexane 2-ol is corrosive, or hexguanine is corrosive, or the phosphoric acid is corrosive. I'll just talk about precaution. Use a fume cupboard. But then the reasoning needs to be really specific. Use a fume cupboard. Well, why? Because volatile organic compounds are toxic / harmful. 5.2. Give a reason for adding the distilled water in steps C and F. So why do we add 10 cm cube distilled water? To remove water soluble impurities. 5.3. Give a reason for adding anhydrous magnesium sulfate. Well, we know anhydrous magnesium sulfate is a drying agent, so we can just say that. Drying agent. Well, yeah, drying agent. It does allow that. 5.4. Complete and label the diagram of the apparatus used to filter the mixture under reduced pressure in step I. So we've got the sponge, obviously got the mixture, then we have and to stir the mixture. Then it says 5.5. Identify the most likely organic impurity other than hexguanine in the distillate collected in step J and suggest one reason why it could be difficult to remove this impurity. Other than hexguanine, hexane 2-ol. And we know hexane 2-ol has a boiling point of 140 degrees Celsius and is likely to have a similar boiling point. So hexane One second, guys. Give me like 30 seconds. Maybe less. Definitely less. Okay. So the impurity, hexane 1-ol, right? Hexane 1-ol, and the reason is it's likely to have a similar boiling point. It is likely to have a similar boiling point. So hexamono is the most likely organic impurity other than hexagonine in the distillate collected in step J. Reason is it's difficult to remove it because it's likely to have a similar boiling point. And then question 5.6 to end question 5. Calculate the mass in grams of hexane 2-ol formed from 11 centimeters cubed of hex-1ene if the yield is 31%. Okay, well, first things first, let's find out the mass of hex-1ene, because that's really, I've got the density, I've got the volume, and we know density is equal to mass of volume, and mass is equal to density times volume. Density is 0.678 times by 11. We don't need to convert any units, that's centimeters cubed, that's gram per centimeters cubed, that's fine. We get 7.458 grams. Let's say 7.46 grams, right? Third step. Well, now we've got the mass of hex-1ene. What can we do with the mass of hex-1ene? We can find out the moles of hex-1ene. How do we do that? The mass, which we just worked out, over the MR. And I feel like the MR is the hardest part of this question. If it gave you the MR, it probably wouldn't have been worth 4 marks. Now, it's not going to be too hard, but it's just a bit long. MR of hex-1ene. Well, if you think about it, it's going to be hex-1ene. It's going to be C6H12. You can even try drawing it out. But yeah, it's going to be C6H12 because it's an alkene, hexene. So yes, CnH2n, 6 carbons, therefore 12 hydrogens. So actually, maybe not that hard. So it's going to be 12 times by 6 plus 12, because we've got 12 hydrogens. MR of hydrogen is 1. 12 times 1 is 12, and then MR of carbon is 12 times by 6 because we've got 6 carbon. So we get 7.46 divided by 84, 72 plus 12, 84, and we get 0.0888. Now that is the moles of hex-1ene. Now, the fourth step. Now we can find out the mass of the product, right? Because we know that it's a 1-to-1 molar ratio from hexane 2-ol and hex-1ene. So we know that the mass of hexane 2-ol formed from 11 centimeters cubed of hex-1ene if the yield is 31%. If the yield is 31%, so 31% is the yield. Therefore, to find out the mass of hexane 2-ol, it's going to be mass of hexane 2-ol. It's going to be the moles 0.0888 times by MR. Hexane 2-ol, well, this one we might have to draw out. It's going to be times by MR times by 0.31, or times by 31 divided by 100, 31%. So the MR of hexane 2-ol, well, we've got 6 carbons, 1, 2, 3, 4, 6. We've got your hydrogens, and we've got an alcohol on the second carbon. So it's C6H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, C6H14. Oh, which is, what's the M of that? 12 times by 6 is 72. 72 plus 14 plus 16. What's 16 plus 14? That's 30. And then 72 plus 30 is what? That's 102. So it's going to be times by 102 times by 0.01, which will give me 2.8 grams. That is the final answer. And that is the end of question 5.